Good morning friends, welcome back to my channel Coding Environment. Today we are going to talk about stack data structure in Java. So if you are a fresher or looking for an IT job at an experience of 1 or 2 years, interviewer can ask you write a program or your own program for stack data structure in Java. So let's see what is stack first so that we can implement it in detail. So what is stack? So let's see what is stack data structure in Java. Stack is a linear data structure in which the addition and deletion of the elements happen in a particular order, commonly known as last in first out, which is called shortly LIFO, or first in last out, commonly known as FILO. So the best example I can think of a stack is the stack of books or the stack of coin. In this, if you observe, the book which is at the last must put at the first. So if you see how we can put these books here, we have to put this green book first, and after that we can put this orange book, and so on. So the books which is at the top will be put at the last, but if we have to take the book out one by one, we cannot take this green book before removing these books on its top. So to remove, we have to remove the book which is at the top, which is we have put at the last. So that's why it is called last in first out. So the book which we have kept at the last will be moved out first. Similarly, it can be first in last out. So the book which is in green color here is put at the first, and it can be taken out from this stack at the last only. So this is justifying its second name, which is called FILO, first in and last out. So let me show you this stack in a form of how we can put the data one by one, and then how we can remove it one by one. So let's see, I have to put one value 10 in a stack. You can resemble this 10 as this green book. Now if I have to put another element in this stack, I have to put that element on top of its 10. So if suppose I am putting element 25, it will come at top of 10 only. Now if you want to remove this 10, you cannot remove this 10 directly. First you have to remove this 25, and then you have to remove 10. Now I am putting some more elements for illustration. Now see, I am putting 15 on top of 25, and then 28 on top of 15. So similarly, I have some elements which I have put already in this stack. So you can see, or I have 7 elements basically in this stack. So the first number which I put in this stack was 10, and then 25 and 15. So if I want to remove this 10, I have to remove all this number which is on top of 10 first. So how I can do that? This is the number which we have put in this stack at the last. So what we have to do is to first delete this number. So this is at the top, and now I have to delete that 55 number. Now if I want to delete all this number, I have to go on the reverse order, like the order in which we have put the data in it. So now I am removing this 40, then 35, then 28, then 15, then 25, and then 10. I can remove it. So this is the way, like if you are putting the data in one sequential order, to remove the data we have to do it in the reverse order. Now what are the operations we can perform on a stack data structure? So if you see, there is basically 5 operations we can perform on the stack data structure. The first is the push. What is push method in the stack data structure? Push is the method where we are putting the data into the stack. Now if I am putting some data on top of this 10, this will be treated as a push method. What is the pop method? Pop method is the method of deleting an element or removing one element from that stack. So push is the method to putting element into the stack, and pop is the method to remove an element from the stack. Now what are the other methods we have in this stack data structure? Is one method which will tell that stack is full or not. So is full is the method which will tell that the stack is full or not. Similarly, we have one method is empty, which will tell that the stack is empty or not, and then we have one method which will tell what is the size of the stack. So these are the basically 5 operations we will perform on any stack data structure. So let's try to implement all these methods one by one, and then we can run these methods on an Eclipse. So let me show you how we can implement all this method one by one. So before we go and implement all this method, first we have to do is to initialize that stack data structure. So in initializing the stack data structure, the first thing we have to do is to initialize the array. What do you mean by initialize the array? Initialize the array means we have to create that array structure. So the first thing which we have to do is to initialize the array. So to implement the stack data structure, we can implement it using either a linked list or either a array data structure. So for illustration, I'm going to use array data structure. Now this initialize is just the declaration of that array. Now we have to also define what is the capacity of the stack data structure. So whenever we are creating a stack data structure, we have to tell what is the size of this stack data structure, or what is the capacity of that data structure, and then we have to initialize the index value. This value will keep the track of the elements which we are putting into the stack data structure. When I'm saying putting into the stack data structure, it means now suppose there is an array and we are putting the element at the 0th index, then this index will keep the value as a 0. Now again, when we are putting the element into that stack data structure, it will go at the first index. So this index is nothing but maintaining the position of the elements which we are putting into that stack data structure. Now after initializing, see in this stack demo, I have to pass the size, which is the capacity, and then I'm doing just initialization of that array and the index value. The index value is nothing but the top, which is I have initialized as a -1. Now the other methods which we have to create is the push method. So what was the push method? Push method was the method where we are going to push the element into that stack data structure. So when I'm saying I have to push one element into the stack data structure, we have to pass what element I am going to push into that stack data structure. So the input of this push element is the integer which we are going to put into that stack. Now when the first thing which we have to do is to check that is the stack is full or not. Now suppose my stack array size is 5 or 3, and I have already put 3 value into that stack data structure, or I have already put the 5 value into that stack data structure. So if I'm going to put my next element into that stack data structure, it will overflow. So that's why we have to check that the stack is full or not. So first condition which we have to check is if stack is full or not. If it is full, I'm going to put that the it's already stack is overflow and my program will be terminated. So for that I'm using system.exit method. Now if my stack is not full, my execution will go to the next line, and as you have seen in my previous initialization time, I have initialized the top value with -1. So in this, if I'm putting my first element or if I'm putting my next element, first thing I have to do is to increment that value. Now this top is first initialized with the -1, and now if I am putting one value, first I have to increment the top 0th index. So if I do top plus plus, the index value will become 0, which is the first index of the array. So if top is 0, and then this array top is equal to x, so the x value you have passed into this method, and I'm assigning this x value at the 0th index into my stack array. Now suppose if I'm putting my next value, which is the, suppose first time I put my value as a 5, and the next time if I'm putting a value as a 6, this method will go and it will check my stack is full or not. For time being, we can assume that the capacity of the stack is not more than 3, or the capacity of the stack is 3. Now I have already put one value, and the second time if I am putting one value, this stack will not be full. and again it will go here and to increment this top. Before this the top value was 0, now it is increment to 1, and then again it will put this x value to the first position. So in this way we are going to push the element into the stack. Now the second method which we are going to learn today is the pop method. So what was the pop method? Pop method was the method where we are going to remove one element from the stack. Now which element we can remove from the stack? The element which we have put at the last into the stack, only that element we can. And how we can get to know which is the last element we have put into that stack? It is very simple, using this top value. Now the top will always maintain the last element which we have put into that stack. The input argument of the pop method is void because it is going to remove the last element which we have inserted into that stack. So this method will also go and check, is there actually any element into that stack? So how we can check it? If the stack is empty, we cannot remove anything, right? Now suppose if there is no value or there is no element into that stack, I cannot go and remove anything. So first thing, if I have to check is the stack is empty or not. If the stack is empty, I will say that my stack is underflow. So overflow and underflow are the terms used in the respect of the stack. If we are putting more element into the stack than its capacity, it will called as a stack overflow. And if you keep on removing and there is no element into the stack to remove, it is called as a stack underflow. Now again, if we are hitting this condition, we will say system.exit and my program will be terminated. If this condition not satisfied, then we will go and see what is the element represented by the top index, because top will always maintain the index where we have put our last element into that stack. So with this we can get to know which is the last element we have put into that stack, and we can return this value. So this is the value which we are going to return from this pop method. Once we get this value, we will do top minus minus. So if we do this top minus minus operation, our index will move one element below that last element which we have inserted into it, and then we can return this return value. So this is the pop method which we have to implement, and we will run these methods into the Eclipse and see how these methods are getting executed too. So after this pop method, we have one method which called isEmpty. So this method will tell that is there any element into that stack or not. So if you see the initialization time, what we have done is like initialize our data structure or the array with the top value -1. So if I check this condition as if top is equal to 1, in this case, if this condition satisfies, it means that there is no element we have put into that stack. Because if we put any element or if we push any element into that stack, we will increment this top value, and if this top value is incremented, it will not be equal to -1. So if this condition satisfied, it means we have not put any element into that stack. So it will return true or false based on the stack is empty or not. Similarly, we have a method called isFull. Now if top represents the capacity -1, or if the top value is equal to capacity -1, it will say that the stack is full or not. Similarly, we have a method which will give the size of that stack. Now the size of the stack is nothing but it will represent how many elements we have put into that stack. So this top +1, it means like suppose my top was initialized with -1, right? Now if I'm putting one element into that stack, there will be, if I'm putting one element into that stack, the size of that stack will be 1. But what will be my top index value? It will be 0. So 0 + 1, it will represent 1. In array, the size of the array is equal to the size of a number of index value +1. So that's what this top representing the index. So index +1 will give us the size value. So let's run that program and see how this program is getting executed. I have put the PowerPoint methods which I have already shown into one class file, and we will run that, and we will run that class file into the Eclipse. So if you see this presentation, This is the initialize portion, which I said that we'll pass the size and we'll initialize the capacity array and the index of that array. After that, we have a push element where we are going to pass the integer value and checking if the stack is full or not. If it is stack is full, we will exit that program itself, and if the stack is not full, we will increment that top value, which is initialized with the -1, and then we will put that element into that array. In the pop case, we will check that the array is empty or not, and if the array is empty, we will terminate the program, and if the array is not empty, we will take the element from the array which we have to return as a part of this method, and then we will decrement the top, or we will decrement the index value. These are the things which we said in the presentation, that we have one initialize method, we have one push method, we have one pop method also, and a part of that we have one size method which will give the number of elements which we have pushed already into that stack, and we have an empty method which will say that the stack is empty or not. So all these things I have already explained into that presentation. And then we have a driver method. So let's put some elements into that stack and see how this stack is behaving. Now I have initialized that class with one variable, or so this is the initialization part of the stack. So I am initializing with the value 3. So this 3 is nothing but the size of the stack. So if you see, it is going and initializing this size, and the size is the array of the size, and this is the capacity also of that particular stack. Now once we have initialized that, we are going to push 3 elements into that stack. So in this case, I am putting 1, 2 and 3, and after that I am going to print what is the size of the stack. So what the size will print, it will print 3, because we have pushed 3 elements into the stack. Now once we have pushed these 3 elements into the stack, we can also pop that out. You remember, there is no input arguments for the pop, so this stack pop will pop which element? It will pop this last element which we have put into that stack. So similarly, this pop will take out this push element, which is 2, and this is the last pop which will take out the first element which we have pushed into that stack, and then it will see again what is the size of the stack. So at this point of time, the size of the stack is 3, because we have pushed 3 elements into the stack. Similarly, at this point of the time, the size of the stack will be 0, because the 3 elements which we have pushed here, we already popped it out, and then if we put this stack pop, it will go and try to pop, but as there is no element into the stack is empty, and the program will get terminated. So let me run this program and show how this output is coming. So now see, the stack capacity is 3, which is saying, it means here we have initialized the stack capacity. Now after that, we have inserted 1, 2 and 3 into that stack. So you are seeing here 1, 2 and 3 we have inserted into that stack. After inserting, the stack size will be 3, because we have inserted 3 elements. Again, when we are saying stack.pop, it is going to pop out that element, which is 3 in this case, which we inserted at the last. So this is the element which we have taken out from the stack. Similarly, the next stack.pop will take this second element, which is this element, Now at the last, if you say stack.pop, it will go and remove the first element which we have inserted into that stack, and after this the stack size will be 0. So here you will see the stack size is 0 here. Now if you do stack.pop, as the stack size is 0, it means the stack is empty, and this will go and say stack underflow. The stack went to the underflow, and if the stack underflow hits, it will terminate the program. So let me run this program into debug mode and show you how these things are working in a like slow motion, I can say, or in the like yeah, this is good. Okay, so now let me run this program, and okay, in the initialize also I will put 1, and yeah, see, I'm going to run this as a Java application, and yeah, switch it. Now you see this. So the first thing it will get called is the stack demo, and it will initialize that array. So here I am initializing the array with the size 3, and the capacity will also be set to 3, and the top value will also be set to 3. So if you see in this, this array is initialized with 3 elements, and there is nothing we have put into this element, so by default value is 0. This top is initialized with -3, and the size is initialized with the 3. Now let's run the code one by one and see how this thing is getting executed. So at this point of time, the capacity is 3. The capacity of that stack is still 3. Now if you push one element, it is going and checking that the stack is full or not. So is that stack is full? No, because we have not put any element, right? So all this element is 0, 0, 0. We have not put any element. So the stack is full, will not get executed, and it will come to the next line. Here it is saying we are going to insert integer 1 into that stack. So see, this x value is 1, and we are going to put 1 into 0th position. Now my top value, if you see here, is -1, but the array index value starts with 0, so we have to increment this. So that's why we are incrementing the top value here, and then we are running this. If you see, this top value becomes 0. Now array top is equal to x. So what we are doing, we are putting this x value, which is 1, into that 0th index of the array. So if I run this program, see, at the 0th index I put 1 here. So similarly, if I'm going to put the 2, it will go and check the stack is empty or full. It is not full, so it will go and increment the top value, and then again it will see here. If you see this array part, it is like 1, 2, and again if I'm running this, 3 will also get inserted. So here, if you see, this array got inserted with the 1, 2, and 3, and this is the last element which we have put here. So top is representing the index of the last element which is into that array. Now if I'm going to print, see, the stack size is 3 because we have put 3 elements into that array, right? Now if I'm going to pop, what it will pop out? It will pop that with the stack.pop, what it will pop out? It will pop out the element which we have put into the last in this stack. So what we put at last into this stack is the 3rd, which is represented by the index 2. Now if you see F6, it is going and checking that it's empty or not. No, it's not empty because there are 3 elements into this stack. And if you see F6, it is removing from the top. So array.top, and the top, if you see, its value is 2. Now it is saying that give me the value of the, now give me the value at index 2. So what is that value at index 2? It is 3. So it will return 3 here. So if you see, it will return 3, and then once it returns 3, it has to decrement this top value also, right? So that now it should point to the 1. That's why it is decremented here. See, this top value got decremented to 1, and now it is pointing to this element, and it will return the value which is nothing but the 3. So removing 3. So here it is saying removing 3. Now once again it will, if we do pop, it will go and remove that, which number? It will remove this number. This is the number because this top value is 1, and it will go and remove this 2. So again, it's, if see, it removing 2, right? It said removing 2, and at the last the top will be 0, and it will removing 1. So once we did this, it removed 0 also. Now if you see that stack size, if I print, it will print stack size is 0. And now if you do that stack pop, what is the value of the top here? Top value is already -1, right? So if you go and see, if I run this, it is going and is empty. So it is checking that the stack is empty or not. So what is that condition we are checking? This top is equal to -1. If you see this condition here, at this point of time, this top value is -1 only, right? So if the top value is -1, it will return you the true, and if this will return true, it will go into this if block, and then it terminate this program, saying that we are already hitting that underflow condition. So if you see, it went into that if condition block and it terminated the program. So this is all about the stack. I tried to show you how we can push one element or how we can pop one element from the stack, what is the working methodology of the stack, how we can get the size and capacity of the stack. So hope you like this video. If you have any doubt or if you have any problem which you want to solve on stack, you can please write it in comments. We will try to solve it. If you like this video, please subscribe it. Thank you for watching it. Have a great day. Goodbye.